I will score ma'am 95 plus. The score you want to score in your class 10th boards. This is rapid revision. We have to keep up the josh to our goal 95 plus in your boards. Hello everyone, and welcome to the rapid revision of the chapter Light from your class 10th physics. We are starting mission 95 plus from a very important chapter, that is of course light. We'll see everything from definitions to laws to formulas to sign conventions in this video quickly. So let's start the revision to our goal 95 plus in your boards. Okay, moving on to the first thing, that is what actually is light. Light is nothing but a form of energy which enables us to see the world around us. Of course, if I close all the lights, you won't be able to see me. So it's an energy that enables us to see the world around us. Now, lots of people have actually come and they have said that light has dual nature, which includes particle nature as well as wave nature. What exactly does that mean? Light is a particle which we today consider as photon, and light is also considered to be a ray, to be a wave that we will study in our +2 in a Young's double slit experiment and all that stuff. Even here you will study prism and all, so those all come under wave nature of light, and you will study photoelectric effect which comes under particle nature of light. Okay, next thing is our first very important topic, that is reflection of light. Reflection of light is what? A light ray came, it hit me and it bounced back. It bounced back and it hit the camera and hit your eyes so that you are able to see me. So bouncing back of light is when it strikes a surface. A light came, it struck this surface and went back. That is called reflection of light. After that, the next topic, that is refraction of light. What is the difference between reflection and refraction? A light came, it bounced back, reflection of light. A light came and instead of me, let's say it went into the water, so it won't bounce back, right? I know water is visible, light is visible inside the water. So bending of light, when it changes one media, when it goes from one medium to another, is called refraction of light. When it passes from one medium to another having different density, air and water definitely has different density, so that is called refraction of light. Yes, keep your josh high, we need high josh here. So a light is coming, instead of going straight, it should go like this, but it bent towards the normal. So bending of light is what we called refraction. Correct? Okay, next thing is, what are the laws here? I told you we'll study about laws. So first law is law of reflection of light. So when angle of incidence, this was light that came and it went back. This is the normal. This is normal, incident ray, reflected ray. When angle of incidence, that is this one, is equal to the angle of reflection. In every case of reflection, angle of incidence will be equal to angle of, angle of reflection. The incident ray, the normal and the reflected ray, the incident ray, the normal to the mirror at the points of incidence, and the reflected ray all will lie in the same plane. Understood? We are done with the laws of reflection. Next is laws of refraction, because we just study what is reflection and refraction. Now laws of refraction is, first is same, the incident ray, but in here instead of reflected ray, it's refracted ray, and the normal to the interference of two transparent media at the point of incidence all lie in the same plane. That is correct. The law is known as, second law is Snell's law. What it says that this is my ray that is coming and this is another media. This is first media, second media. Instead of going straight, it bends, correct? It bends. So this angle is called angle of incidence. This angle with the normal is called angle of refraction. Angle of refraction. So the sign of angle of incidence to the sine of angle of r, their ratio will always be constant. So I have two laws of reflection and I have two laws of refraction now. Okay, understood? Moving on to the next topic, that is we have two types of, now we want to study about optical, optical instruments. We have mirrors, we have lenses, we have microscopes and telescopes, lots of things, right? All the basis of all that big telescopes and all that microscopes are lenses and mirrors. To study those, in this chapter we'll study spherical mirrors and we'll study later spherical lenses. We have two kinds of mirrors. First is what? First is concave mirror, the one which is shaped like this, and the light, it's like a cave and the light is going inside the cave, is called concave. Yes. And the second is convex, just the opposite. It's shaped in the opposite direction and the light is incident on the other side of the cave. This is inside of the cave. When light is incident on the outside of the cave, that is called convex mirror. Now one more thing you can remember, concave mirror is always converging and convex mirror is always it is diverging. Correct? Okay. Next thing is the image formation by concave mirror. We have 6 cases. When the object is at infinity, image is formed at focus. Object is beyond C, image between C and F. Object at C, image at C. Object between C and F, image beyond C. Then object at focus, the image at infinity, or you can say the image is not formed. Then image object between F and P, and the image is behind the mirror. This is one exceptional case. In all these 5 cases, the image is real. It is what? It is inverted and it is of same sizes, greater, point size, smaller, diminished, everything. And in the 6th case, the image is virtual and erect and it is larger in size. Correct? Moving on, we have image formed by convex mirror. We have only 2 cases in convex mirror. First, the object is at any point between infinity and focus. Any point between infinity and focus, the image will formed behind the mirror. It will be virtual, it will be erect, and always in case of convex mirror, the image is always diminished. So you can clearly see it is diminished and it is between pole and focus. Focus is something here, pole is here. It is always between pole and focus. The second case is when the object is at infinity. Then the image will always be forming at focus. Correct? Okay. Then the nature of image formed by spherical mirrors. So by concave mirror, I told you real as well as in 6th case virtual, all sizes, inverted as well as in 6th case erect. But in case of convex mirror, the image is always virtual, it is always diminished, and it is always erect. Okay. Then moving on, we have refraction from glass slab. We studied refraction is bending of light when it changes its media. So this is air and this is water. So my light is incident on this water. So instead of going straight, it bends towards the normal. And then if we continue here, it is also normal. Now this is water, this is air. Again the medium is getting changed. But now this is denser to rarer. This was rarer to denser. So instead of bending towards the normal, it will go away from the normal. Now this incident ray and this is called emergent ray. Incident ray and emergent ray are parallel to each other. Incident angle can be equal to emergent angle. Correct? This is incident angle, refracted angle, and this is my friend emergent angle, emergence angle. Okay, we have spherical lens. Again we have 2 types of lenses. First is concave lens, just like concave mirror. Second is convex lens, but their function is inverted. We have 6 cases in case of concave mirror, but here we have 6 cases in case of convex lens. Okay, and 2 in convex mirror, here 2 in concave lens. Let's look at those. Image formation by convex lens. Similar. Okay, at infinity, image is at focus. Then object is beyond 2f1, image between 2f2 and f2. Just remember, the image will be forming on that side of the lens, because lens is not reflecting, it is refracting. Then the object is at 2f1, the image is at 2f2. Then between 2f1 and f1, the beyond 2f2 image at f1 at infinity or not formed. Then the sixth case, again the exceptional one. Here the object is between f1 and optical center. So instead of forming on this side, it is forming on this side of the mirror. The image, it is enlarged, virtual and erect. Correct? In all these 5 cases, again this is real, inverted and of all sizes. Correct? Then image formation by concave lens. Concave lens, again we just have 2 cases. First is at infinity. At infinity the image is formed at focus, but in this case it will be formed on the same side as that of the object. Oof. This is the rapid revision, we have to keep up the josh. Okay, then in second case, the object is at any point between infinity and focus. At any point between infinity and focus, the image will be formed between, on the same side, but between the first focus and the optical center. Now, in case of convex lens, we have real as well as virtual. In the sixth case, all sizes, inverted as well as erect in sixth case, we know that. Then concave lens, but always virtual, always diminished, always erect. Okay. Okay, what is left? Oh, the main thing, formulas. For mirror formula, this is the most important slide. This chapter includes lots of numericals, so this is very important slide. Formulas, the first is mirror formula. Now, mirror formula, just 2 formulas. 1 by f equals to 1 by u plus 1 by v. This is image distance, this is object distance, this is focal length of the mirror. Okay, then we have magnification, height of image divided by height of object, minus magnification in case of mirror is minus v by u. This minus is very, very important. Okay, in case of lens formula, we had here plus. In case of mirror formula, we have 1 by v plus 1 by u. Here 1 by v minus 1 by u. Correct? Lens formula is 1 by f equals to 1 by v minus 1 by u. And in case of magnification, there is no negative sign here. Can you see? No negative sign. The formula is same, v by u, but here minus v by u in case of mirror. In case of lens formula, this is only plus v by u. Understood? Only one thing left, I hope. Okay, we have one more thing, that is refractive index. This is the single slide that you need to remember for all your refractive indexes formulas. Okay, so all your refractive indexes, numericals as well. So N21, see, this is my first medium, this is my second medium. Light is going like this, let's say. Okay, and this is normal, it is bending like this. So N21, N2 divided by N1. N21 is N2 divided by N1. Now velocity is inversely proportional to refractive index. Of course, ma'am, light will travel faster in air than in water, but refractive index of water is more than air. So of course they are inversely proportional. So N2 by N1 will be equal to V1 by V2, and they will be equal to sin I divided by sin R. Okay, understood? Then what next? Power of a lens. Again, very, very important formula, very simple formula. This is just 1 by f. F is what? F is focal length of the lens, focal length of our lens. But very important point, this focal length should be in meters. Only then the unit of power will be diopter. Okay, make sure this is not in centimeters, convert it into meter first. Okay, okay. One most important, again one more important slide is left, that is sign convention. All your formulas, all your numericals require one important thing, that is sign convention. Okay, so above the principal x is positive, below the principal x is negative, I know that. Then left hand side of the mirror or the lens, this is mirror or this is lens, correct? This is left hand side, this is right hand side, left, right. All the distances on the left hand side will be negative, all the distances on the right hand side will be positive. On the distance on the right hand side will be positive, just like your Cartesian coordinates, just like x-axis, y-axis. Focal length in case of concave mirror or lens, for both lens as well as mirror, concave lens and mirror has negative focal length, and convex mirror or lens has positive focal length in both mirror and lenses. Then u is always taken as negative. Object distance is always negative. Then magnification, for negative magnification it is real and inverted. Magnification negative, that means real and inverted. Magnification positive, that means the nature of image is virtual and erect. Okay, this is all about sign conventions. Then these are some of the important topics that you should definitely study. You should definitely take care of numerical sign convention ray diagrams, practice them daily, use a spherical mirrors, refraction through a glass slab. And hence we are done with the rapid revision in 15 minutes. We have revised the whole chapter of light in 15 minutes. I'm very proud of all of you. Now I want you to participate in Mission 95 Plus and comment down the score you want to score in your class 10th boards. Comment down and say that I will score, ma'am, 95 plus. Comment down, I will score 95 plus. Okay, let the universe know that you will score 95 plus. Power of manifestation. Okay, I'll meet you in the next rapid revision. I'll be coming live with top 100 MCQs from these physics chapters. Be ready to join that. Bring your pen and paper, bring your brains. Be ready to score 95 plus in your class 10 boards. Till then, tada, bye bye.